Good morning, everybody. Today we're going to be starting Unit 8, Lesson 8. So please get out your pages and follow along. Obviously, you can see that we're doing word problems for quadratic, so the topic is definitely not easy. However, the questions aren't that challenging, and it uses the same formula over and over again. So we should be able to get through it. So that, again, with word problems, the hardest part is probably going to be for all of us making sure we get the initial equation right. Once we do that, we are going to be using factoring to find the solution for the quadratic as our way to find the solution. So let's begin. So make sure you have it in front of you. Make sure you have your calculator in front of you and follow along. And please do what I do so you feel comfortable with this when you get to the homework. So we have a rectangle whose area is 45 square feet. If we know the length of one, if the length is one less than twice the width, then find the dimensions. So we know the area of a rectangle is length times width. You know that I always draw a picture. And I'm going to write the area is 45. It says the length is one less than, so it's going to be one less than twice the width minus 1. Remember, when we do one less than, we always do minus 1, and we do the 2w in front. And the w is going to be here. Now they want us to set up an equation. So we're going to do length times width. So I'm going to do 2w minus 1 times w, and that equals 45 for my area. Good. So now it says we're going to find the dimensions. It also says why is w, the solution for w, not viable. So let's first solve it. So let's put this down here again. 2w minus 1 times w equals 45. Remember, what we want to try and do when we're solving a quadratic using factoring, we want to get everything over to one side, standard form equal to 0. So let's first distribute the w. We get 2w squared minus w equals 45. Now I got to get that 45 over to the left-hand side. So I'm going to subtract 45 to both sides. I'm left with 2w squared minus w minus 45 equals 0. Now, of course, they had to start us off with a factoring where the lead coefficient is not 1. Not a big deal. We know that 2 can only be 2 times 1. So I know my first set of numbers is going to be 2w, and this is going to be w, right? So I have to figure out what I'm going to do for the negative 45. Well, good news is 45 doesn't have too many options. It has 45 times 1, yuck. We have 3 times 15. I'm not loving that one either because I want to get close to 1 or negative 1. So let's also try 9 times 5, and that's all there is. So I certainly don't want to multiply 2 times 9. That number's way too big. And any other number is not going to get me close to negative 1. So let me do this. Let me try and put in, I don't know, let's put the 5 here and the 9 here. That way when I multiply, remember we're doing O and I. When we're doing FOIL, we're doing the O and the I. So the outer, in this case, let me do the math over here. So I do 2 times 5, which is 10. And I do minus 9 times 1, which is minus 9. So it's not going to be 5 and negative 9. It's going to be 2 times negative 5, and it's going to be plus 9 times 1. So I'm going to add the 9 here, and I'm going to subtract the 5 there. I know when the lead coefficient is not 1, it's a lot trickier. I know that, but we have to definitely keep working at it. That's all I can say. So the work I did over on the right in green is what I'd want you to do is I want you to think about different things you can do to get to the answer. So let's now solve it. So we're going to put the line down the middle. We get 2w plus 9 equals 0, and we get w minus 5 equals 0. So w equals 5. That part's easy. Now we're going to get 9 by itself. Is it okay for it to be a fraction? Of course it is. What's the problem with the numbers on the left? What's the problem with the numbers on the left? W equals negative 9 over 2. It's negative. We can't have a negative number. So x can't have negative length, right? Or width, right? So this is the only correct answer, but we're not done. So they want to know the dimensions. So if the width is 5, I go back to my let statement, then my length is going to be 2 times 5 minus 1, which is going to be 10 minus 1, which is 9. Okay? So we have 9 and we have 5. Certainly some of you probably could have figured that out on your head because 45 was the area, but you have to show it algebraically, so this is what we have to do. Okay? Let's move on to question 2. A little bit easier. A square has one side increased by the length by 2 inches and an adjacent side decreased, which is the other side, by 2 inches. If the resulting rectangle is an area of 60 square inches, what is the area of the original square? So let's draw out a square and let's draw out the rectangle. So if they're saying the square, we don't know what the area is, but they're saying we know that the square has all the same sides, so therefore they're all x. So they're saying that the one side is increased by 2 and the other side is decreased by 2. And that area is 60. Okay. So we are going to solve this first by, they want to know what the area was of the square. What was the original square's area, right? We first have to find out what the rectangles was. So let's go ahead and do this. So if we do area equals length times width again, that's nice and easy. We do x plus 2 times x minus 2 equals 60. So let's put everything together. We're left with x squared minus 4x equals 60. I know that they are the difference of two perfect squares, so I don't need to do the outer and the inner, but I could, and it would have come up with the same answer. Now I'm going to get the 60. You know what I'm going to do? Yeah, over there. So I'm going to put x squared minus 64 equals 0. Now, the first thing I do is I look when I'm going to be factoring is to see if there is a GCF. There is not. So then I say, is this also a perfect square? X squared is a perfect square, x times x. Let me do that. This is x times x. This is from Unit 7, Lesson 4. And then I know that 64 is also a perfect square, 8 times 8. So I'm going to now do the difference of two perfect squares again. So I'm going to do x plus 8. I'm going to do x minus 8 equals 0. Put the line down the middle, set them both equal to 0, and we get x equals negative 8 and x equals 8. I can cross off. This is not good. It's a big X, right? Can't have it. So x equals 8. I don't have to go to the area of the rectangle anymore. I can go right up to the area here. And sure enough, the area 8 times 8 is 64 inches. Is it inches squared? Yeah, inches squared. And that's my final answer. So the area of the square was 64 inches squared. Okay? Take a moment to look at the work, and I will move on to the next question. So now we can have problems where there's no pictures, and we now start writing some let statements potentially. There are two rational numbers that have the following property. When the product of 7 less than 3 times the number with 1 more than the number is found, it is equal to 2 less than 10 times the number. Find the two rational numbers. So I'm going to write the first number. I'm going to write the second number. So remember, when I make a picture, that's my let statement. When I don't have a picture, I have to do a let statement. So the first number is the product of 7. So the product's going to be multiplication, right? It's going to be multiplication. 7 less than 3 times the number. 7 less than 3 times. When the product of 7 less than 3 times the number with 1 more than number is found, 7 less than 3 times the number with 1 more than the number is found, it is equal to 2 less than 10 times the number. So we're going to have okay. 7 less. So sorry about that. I don't know why I had to say it so many times. 3 times the number minus the product of 7 less than, good, 7 less than 3 times the number, with, so the with is the multiplication, 1 more than the number, and plus 1 is equal to 2 less than 10 times the number. 2n, sorry, I'm going to change this, 2n minus 2. 10n minus 2. Okay, so let's start distributing, FOILing the left-hand side. So we're left with 3n squared plus 3n minus 7n minus 7 equals 10n minus 2. So now we're left with 3n squared minus 4n minus 7 equals 10n minus 2. We're going to add 2 to both sides. We're going to subtract 10n to both sides. 3n squared minus 14n minus 5 equals 0. So now we have 2 prime numbers that we have to factor with. So I know the first one has to be, let me change the coloring, has to be 3 times 1, 3n, and this is going to be n. And we know this one has to be either 5 times -1 or -1 times 5, but I don't know the order. Now I look at the number 14. It's a very big number. So I have to get to that number quickly. So off to the side, I'm going to do some math. I'm going to do 3 times what and 1 times what is going to get me to -14. So let's see. So I know I'm going to multiply quickly with this 15 multiplied to get 5 times 3. So let me try that. Do 5 times 3 and plus 1 times -1. That gives me 15 minus 1, which is 14, which is close, but that's not right. So to flip-flop, I'm going to do, instead of having a positive 5, I'm going to have a -5. So now let me try that. So I'm going to do 3 and 1, and I'm going to do 3 times -5 plus 1 times 1, and that's going to give me -15. It's -15 plus 1, which is -14. So this is going to be what we're going to use, right? So I'm going to put in the -5. I'm going to put the -5 here, and I'm going to put the +1 there. All right, and that equals, let me say, equals 0. So now what I do is I make my line down the middle. I get 3n plus 1 equals 0, and I get n minus 5 equals 0. When I do the math, look at this. I'm already seeing equals 1 over 3, and this n equals 5. So what do they want to know? They wanted to know, find the 2 rational numbers that fit this description. There are 2 rational numbers that have the following property. Okay, so we have a solution of 5, and we have a solution of -1/3. So let me just see here. 2 rational numbers that fit this description. So the product of 7 less than 3 times the number with 1 more than is found is equal to. So the 2 rational numbers that fit the description. There are 2 solutions. You can either have a -1 over 3, or you can have a +5. Okay, so let's go on to the next question. Consecutive integers. Find all sets of 2 consecutive integers such that their product is 8 less than 10 times a smaller integer. Now with consecutive integers, remember we have to do the let statement where we have consecutive integers are going to be n plus 1, n plus 2, n plus 3, etc. Consecutive even and odd integers are going to be x plus 2, x plus 4, x plus 6, etc. The thing about consecutive integers is they can be either negative or positive, so it doesn't matter if it's negative or positive. So let's go through this. So we're going to have the first number is going to be n, and our second number is consecutive integers, which is n plus 1. Okay. Their product is, so the product of the 2 numbers, so I'm going to do n times n plus 1 is, this is 8 less than 10 times the smaller integer. 10 times the smaller integer. I know n is smaller than n plus 1 always, and we have 8 less. So let's now do the math. Boom, boom. We get n squared plus n equals 10n minus 8. I'm going to bring everything over to the left. So let's subtract 10n, and we're going to add 8. So we're left with n squared minus 9n plus 8 equals 0. Finally, our first traditional factoring problem. We haven't seen one yet today. So I'm going to have the factors of 8, when added together, give me -9. Now my clue here is that the 8 is positive, but the -9 obviously is negative. So I know that both numbers have to be negative. So the two numbers, there's obviously -4 times -2. There's also -8 times -1. So this added together gives me -6. That's no good, but this gives me -9, which is correct. So my two numbers I'm going to use are going to be n minus 9. Oh, n minus 8, sorry. N minus 8. Let me erase that. N minus 8. And we're going to use n minus 1 equals 0. Make your line down the middle. So therefore, n equals 8 and n equals 1. So what are the two sets? There are two sets. We can have 8 and 9, and we can have 1 and 2. Okay? Because the solution, n was both 8 and 1. So therefore, the solution is 8 and 9 and 1 and 2. Okay, I believe I have one more set of questions. Okay, so this one is a little combination of some math and then some number sense and then a word problem. They want us to prove how to find the other number. So Brendan claims that the number 5 has a property that the product of 3 less than it with 1 more than it is the same as 3 times 1 less than it. Okay, so let's see what we need to do here. So they're saying with the number 5. So let's use the number 5 in this problem. So we're going to do 5. So they're saying 5, 3, the product of 3 less than it, fine, with, the with is the times, 1 more than it. This problem is really kind of weird. Is the same, that equals, is the same as 3 times 1 less than it. So 3 times 5 minus 1. They say that that's the same. Okay, let's just confirm it's the same. So we get here, this is minus, so we get 2 times 6, and we get here 3 times 4. So we get 12 equals 12, so they are correct. So how can I make this true, and what's the other number to make it true? So I'm going to replace the 5 with an n. So every place here I have a 5, I'm going to replace it with an n. So I'm going to get 2 times n minus 3 times n plus 1, and that equals 3 times n minus 1. So now let's do the math, and let's see what the other number is that makes this true. So we distribute, we're going to do foiling. We do n squared plus n minus 3n minus 3, and that equals 3n minus 3. So let's get everything over to one side. We're going to subtract the 3n. We're going to add the 3n. We're left with n squared. Oh, this becomes negative 6n plus n is negative 5n equals 0. Let's factor out a GCF, which is an n. We're left with n minus 5 equals 0. So the two numbers we can see are n equals 5. We knew that already. The other one is 0. So the second number is 0. 0, right? What are my takeaways from you today? I want you to take your time with these problems. I want you to follow along. I'm going to put these notes up on the website as well, on the Google Classroom. And we are going to be able to do the homework. The homework is going to be Unit 8, Lesson 8, all. We will then do some more review tomorrow. And then we are going to have a test on Unit 8, Lessons 4, 5, 6, 7, and 8 on Thursday. So we will get caught up with that. You guys have a wonderful day. I will be here for office hours on Tuesday from 1 to 2. Have a wonderful day, everybody. Bye now.